Okay, today we're going to take a look at standard LEDs and infrared transmitters. Now I have here a red, a green, and a yellow LED, which are the three smaller devices in my hand. And then this is an infrared transmitter, which is the bigger device. So it's normally used in an opto switching circuit, where you have an infrared transmitter on one side, and then you have an infrared receiver on the other that sees this light, and when something goes between the two and breaks the beam, it can trigger a switch or an event. Now, the LEDs I have here are the small variety. These are the only spare ones I had lying around to be able to use in this situation, but it doesn't really matter. They're more or less the same in terms of things like voltage and viewing angles and things of that nature. I have my variable power supply here, and we're going to hook each one of these up to the variable power supply and see what it looks like and see what the current draw is for each one of these. So let me start with the traditional red LED, and it has a short lead and a long lead on it, and for the purposes of these testing and hooking up to the power supply, the long lead will get hooked up to the positive lead on the power supply, and the short lead will get hooked up to the negative lead on the power supply. Now, right now, the power supply, I have it outputting 1 volt, and as you can see, there is no light being emitted from this LED at 1 volt. But what I'm going to do now is I'm going to crank the voltage up slowly, and we're going to watch the LED. That's 1.1, 1.2, 1.3 volts, 1.4 volts, 1.5 volts, and actually I think we can start to see a little bit of light coming from the LED. And now we're at 1.6 volts, and there it is. You can see a little bit of light. 1.7 volts and 1.8 volts, and now you can see this LED is blazing, and we're at 1.9 volts, and we go to 2 volts. And typically a red LED turns fully on at 2 volts, and we can see that this one is fully on, and this is currently using about between 25 and 30 milliamps according to my power supply. So as you can also see, you can see this LED from all angles that it's on, and that's important, and you'll see why later when we look at the infrared LED. So there's your red LED, and if I disconnect it, you can see it goes off. And so now let's reset the power supply back to 1 volt, excuse me, and we'll try the yellow LED. And the yellow LED is the same. You have, all LEDs are the same really. You have a short leg and a long leg, and the short leg always goes to the negative and the long leg goes to the positive. And now we're going to do the same thing. We're going to start turning up the voltage on this yellow LED. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, and there you can sort of see it starting to come on. It was probably coming on at 1.6, but because of the yellow light, it was a little harder to see. I get to 1.8, 1.9, and 2 volts. And yellow LEDs are like red LEDs from the standpoint of their, what they call their VF, their forward voltage, and when they fully turn on. And they both are supposed to be fully turned on at about 2 volts. If you look at a data sheet for an LED, you'll see that their VF is typically 2 volts, but it's actually can be a little bit less than that. I mean, and the current being used by this is about 10 milliamps. So this is a yellow LED, takes about half of the power of a red LED, and you can sort of see the intensity of it here when I put my hand behind it. So there's your yellow LED. Now we can disconnect the power again. Now we're going to go to our green LED, and again it's the same. Oh, first we're going to reset the power supply back to 1 volt. And then we hook up our power leads. And now we're going to start cranking the voltage up on the green LED. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, and you'll notice that there the green is starting to kick in at 1.7, but the yellow and the red kicked in a little bit earlier. 1.8, 1.9, 2.0, and you can see now we're at 2 volts, and there's less than 10 milliamps that's being drawn by the green LED at 2 volts. But you'll notice if I crank up the voltage on this a little bit more, and now I'm at about 2.3 volts, and you can see there's the 2.3 volts, and if I take this back down to 2 volts and look at the intensity difference, there's 2 volts, and then we're going to do 2.3 again. Green LEDs typically turn on more towards 3 volts rather than 2 volts. And you can see by cranking the voltage up here a little bit more, I get more green LED light out of this. This isn't the high quality LED, so I'm sure it's not as pure as a regular green LED would be, and as a result it's turning on below at around 2 volts. So but there's your green LED, and again, just like the yellow and the red, you can see the light being emitted from this from any angle. So now let's reset our power supply, and now we go to our infrared transmitter. And again, you see you have a short and a long leg, and the short leg goes to the negative and the long leg goes to the positive. Now there's 2 things to note here. One is that since this is an infrared emitter, you can't see this with your naked eye. You can't see the light being emitted from this LED with your naked eye. Unfortunately, I can't show that because I'm using the camera, and the CCD and array camera can actually pick up the infrared light being emitted by this. The other thing about infrared LEDs is that the beam that comes out of the infrared LED is focused. It's usually about 15-degree angle from the top of the LED. So for that reason, what I'm going to do is I'm going to turn this. Now I have to make sure the wires sort of work with me here, so that we can look directly in the top of the LED as I start turning the voltage up. So here we go. We're at 1 volt now, 1.1, 1.2, and you'll notice I'm already at 1.2 volts, and you can see this starting to glow. Now I take it up to 1.3, and now you can see this is blazing. And if I go 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and now I am at 2 volts, and my power supply is telling me this thing is pulling 280 milliamps. Much more power at 2 volts than what we saw from the other LEDs. And the other thing to note about this is if I turn this sideways, you'll notice the light disappears. This looks just the same right now as it would if I had the power turned back down to 1 volt. And in fact, I'm going to turn the power back down to 1 volt, and you'll see nothing changed here. And now I'm going to turn it back up to 2 volts. And you see it still looks the same. So infrared LEDs require them to be aligned and focused with their receiver ends, otherwise the light won't necessarily be seen by the receiver. And now, just to show, I'm back at 2 volts. You can see there it is, the LED blazing again. And if I turn this voltage back down, and now I'm back down to 1 volt, and you see it doesn't turn on. So the other thing about infrared LEDs is that their forward voltage, their turn-on voltage, is actually lower than it is with a standard LED. And we're going to prove that now by using the DCA Pro to look at the turn-on voltages of each one of these devices. So first we'll start with the infrared LED, since I have it in hand. And I'll hook up my leads, my test leads, and I will press the test button, and you'll see as it tests it'll blink the LED, so that's how you know it's figuring out what it is. There it goes, it's running the test. And as you see, it actually says here the forward turn-on voltage for this infrared LED is 1.3 volts, which we saw in the video, when we had this hooked up to the power supply. Now let's disconnect this and hook up the red LED. And by the way, the DCA Pro doesn't care what leads you use to hook up to it. It'll just automatically figures out, you know, what you're actually doing, and it does it automatically. So now if I press the button again, and you see the LED flashes, and this is a red LED, and you see it says here that it's an LED. It actually knows it's an LED, and its forward voltage is 1.786 volts, and again we sort of saw that in the video. And now let's look at the yellow LED, and we'll hook this up. Okay, and then you just sort of see the glow from the ambient light here. I'll press the button, and then you can see it blinking, and its forward voltage is actually more. It's 1.902 volts, or is that 1.8? That's Well, 1.902, yeah, I was right. So you can see the yellow LED actually has a slightly higher forward turn-on voltage than the red one, at least in this particular instance. And you can have variations from LED to LED, and even within the same batch, it happens. And finally, let's look at the green LED. And you see here the forward voltage is the highest of all three of the LEDs. It's 1.984, almost 2 volts before this one actually even turns on. So there you see the differences in the colors and the differences in the types of LEDs, in terms of their turn-on voltage, in terms of their power consumption, and in terms of their viewing angle. I hope this helps you when you need to find an LED in the future, whether it be a visible or infrared for your particular application. Thanks.